So sometimes when you look at a problem, you can tell that it's going to require the integration by parts more than once. We call that repeated applications of integration by parts. And things that will do that is if you have cosine of something and then x to a power, same thing with sine of something and x to a power. And then also if you have e to the x and x to the power. So anytime you see those, you're going to have to do repeated applications, usually however many times, whatever the power of x is, that's how many times you're going to have to do it. And we saw that in the last two problems. So when you see problems that look like this, and you know that you're going to have to do integration by parts more than once, it's helpful to set up a table. This is also really good if you can see you're going to need to do integration by parts like 4 times. You definitely want to go with the table. So we're going to use this to find the antiderivative of x squared sine of 4x dx. You can see from the previous ones we did, this is going to be integration by parts more than once. So here's how this works. You set up 3 columns. So one is just alternating signs. You start with positive, and you're just going to go positive, negative, however many times we need to do that. We may not need that many steps. U and its derivatives. So remember, use the part of it that gets simpler. Okay, so in this problem, u is going to be x squared. And then we are going to take the derivative of x squared, which is 2x. We're going to take the derivative of that, which is 2. Then we're going to take the derivative of that, which is 0. And that's when we stop. Stop at 0. Okay, which means I didn't need all of these. Okay, basically we're going 4 steps. Okay, so negative. Oh, that was supposed to be, sorry. Negative, positive, negative. Okay, so then the other part of it, sine of 4x is dv. And we need to take the antiderivative of all of these. So the antiderivative of sine 4x is going to be negative cosine 4x, but then the chain rule, we have to do a 1/4 with that. And then we need to take the antiderivative of that, which is going to be negative sine 4x, but we're going to need to account with another 1/4, so it'll be 1/16. And then we want to take the antiderivative of that, which is going to be, I think, a positive cosine 4x. And we're going to need another 1/4, so 1/64. Okay, so that's what our table looks like. Maybe we should write those numbers so you can actually read them. Might be a good idea. Okay. All right, and then the way the table works from this point is, let me get a little arrow thing. We'll use pink. This sign goes with that, and it picks that. So that's your first term. So your first term is going to be positive x squared times negative 1/4 cosine 4x. Your next term is going to be negative times that, and then times that. So our next term will be negative 2x, and we're going to multiply that by negative 1/16 sine of 4x, which I realize I need to clean that up. And then the next one will be positive 2 times that. So we get positive 2 times 1/64 cosine of 4x. And then the last one, well, we ran out because we stop at 0. Okay, there's nothing left. It's negative times 0, so it doesn't matter what's next. The next thing is just 0. So our final answer is going to be negative 1. Oh, let's get a pencil. Negative 1/4 x squared cosine 4x plus 1/8 sine 4x plus 1 over 32 cosine 4x plus c. Okay, so the table method is really nice if you have to do the integration by parts more than once. Even if you only have to do integration by parts once, you can still use the table method if it works for you. It's just a nice way to organize these things. So that is integration by parts. Hope that makes sense, and please let me know if you have questions. I'll be happy to walk you through more of these.